there's some, there's some very serious storms occur in this lake, and depending on the wind direction, there could be some significant dispersal of that cap in that harbor. I mean, there's been damage before, not necessarily from the direct wave action, but the bounce back. And, that's a big unknown.
Yep. Well, and, again, it's been a pretty serious topic of discussion, not only tonight, but it seems like an obvious issue when we talk about subaqueous capping, or what we talk about in terms of caps being placed under any sort of water feature. There's always going to be those forces at work at that capping system. This, what we call a sand layer capping, it's a coarse granular material, so it's not a fine silt or clay material that can be resuspended and transported for long distances. Those materials, even if they get resuspended, do fall out relatively quickly, and I say relatively. Now, I understand that there's big storms that come through, and I'm from Halifax, so I know all kinds about all about coastal environments and storms and storm surges. So those are the type of things that we look at when we design these caps, and that's why when we look at movement of materials across the site, we're okay with some movement of the material, and we don't expect that material to get swept right out of Jellicoe Cove, and all of a sudden 5 years later we've got no evidence of that sand cap. In fact, we've seen that application of thin layer capping or those materials being applied on sites that are probably more dynamic than what we see here in this location. So, we've seen we've had some experience in applying these things, but even when we look at the design, we want to make sure that the capping, the selection of the material size is sufficient that we don't mind some movement, but that we are pretty confident that we're not going to see, even with big storm surges, we'll see that movement of material, but we're not going to see it just wipe that capped area completely bare.
Is there specifications on the size of the cap material?
There is, and David will talk a little bit about that specification. The one thing that we're trying to balance out a little bit too, and if we were as an engineering firm, if we wanted to be confident that that cap's not going to move, we'd come in and we'd rip wrap that sucker, and we'd have all kinds of big material in there and say that's never moving. But of course, the trade-off is that you all of a sudden decrease the depth of that channel in those areas. You start to restrict the ability to use those areas for vessel traffic. And so we're trying to balance off, well, we don't want to impose any restrictions on the use of that site from vessels, whether it's current or any future planned use. But we want to have a capping material that has enough substance and granular material in it that even if it does move, it's not going to exit that site entirely. So it's a bit of a trade-off. I mean, we come in and engineer this thing to death and have a cap there that will never move. But I'm not sure if that's really what's required here, and I'm not sure that really the offsetting risk that you have there is reducing your draft for vessel traffic in the future.
And I'd add that that sort of intuitively you think about that sand cap and you can envision the currents and the wave action and it moving it around, and by design the intent is that it can resuspend, as Sean said, settle back down, and the real question at the end of the day is whether you end up with a net scour. So it can move around a bit, but as long as it's moving back and forth and resettling, you haven't affected the integrity of your cap. However, if in the worst case you had a net scour and you're moving it out, then you would, right? Over time you'd remove your cap, and that would clearly be a problem. So as to your point, it's a good one. Part of the design specification for the material has to contemplate the level and the net movement created by storms and currents and depth fluctuations, and that's part of the modeling and the underlying design engineering that goes into specifying the material. So when the contractor who's ultimately retained to do the work, they will work to a defined specification that, if we've done our job right, will result in a cap that can move around a bit, but not net erode.
So what you'll see with storm surges and other kind of scour events is that you'll see mounding happening in certain areas, but those mounding events will also redistribute themselves. I mean, those mounds are not conducive within those dynamic environments themselves. So you know, what you'll have with the next storm event or the next, wind event, you'll have redistribution of that material. And so as David said, we're okay with some movement around, and we don't expect to see that site, as I said, just strip bare and have it all redeposited somewhere on the other side of Skeena Island. We expect it to have some movement, some exposure of contaminated sediments, but generally that's okay, as long as we see that the integrity, or at least the majority of the site still having some